this video covers normal curve and z-scores. And so we are going to take what we know about standard deviation and probability, and we are going to create something called a z-score based on some of the properties that we know about the normal distribution and the normal curve. This one is going to be divided into two parts as to keep it from getting too terribly long. So what do we know about probability in the normal curve? Well, basically a z-score is a standardized score. It basically represents the number of standard deviations from the mean a particular variable is. With a single interval or ratio level variable, so a numeric variable, that we have reason to believe is normally distributed in its population, so it has that normal curve where the mean, the median, and the mode are all the same. We can compute standardized scores or z-scores, and we can use them to determine the proportion of a population's scores falling between any two scores in the distribution. So this goes back to what we talked about with how to interpret standard deviation. If you remember, about 70 or 68% of cases fall within one standard deviation of the mean. So using a z-score table, we can compute z-scores and use them to determine any area under the curve, and not just the 1, 2, and 3 standard deviation percentages. So the first thing we have to do is we have to identify part of the curve by using the z-score calculation, and then we compute the proportion of the total curve this part represents. And then we use the table that's posted underneath this video, Appendix C. It's also, you have a table that's very similar to this in your textbook, and this table will allow you to see what proportion is between the mean and that z-score. So let's go ahead and look at the table. So here's the table. So this is the area under the normal curve. So basically this table is looking at this shaded area here between 0, which is 0 standard deviations, or the mean, and whatever our z-score is, however many standard deviations away from the mean that we're looking at. And so this table gives us that proportion, and if we multiply that proportion by 100, it will give us the percent of the area that this represents. And so you can see this table, it doesn't quite all fit on the screen, but it's pretty long. The way that you would read this table is once you have your z-score, you look down this first column and you'll see that it's 0.0, 0.1, 0.2, and it goes down to approximately 4. And so that's the tenths place. So we always round to the two decimal places. So this first column is giving you the first decimal place. And then over across the top you have 0, 0, 0.01, 0.02, 0.03. This is the hundredths place. So this is going to your second decimal. And so if we're looking at 1.00, it's going to be here, 0.3413, or 34.13% of the respondents are between the mean and one standard deviation above the mean. And so that's how we would go ahead and use this table. So again, what this table is showing us is it's showing us the percent or the proportion between the mean and whatever our z is. So this kind of shaded area. And so the table keeps us from having to calculate that by ourselves and how to calculate the area under the curve. But that's basically what we're doing, is we're looking for the area under the curve in a normal distribution. Alright, so how do we calculate z-scores? The formula for z-scores is pretty simple. It's the z for any given number is that number, x, minus the mean divided by standard deviation. And so again, you're looking for the average distance away from the mean. So we're going to go ahead and do an example in the next set of slides. So go ahead and click on the continuation on YouTube, and we'll go ahead and do a sample.